Okay, so in this video I'm back working on the Wren executive computer system. If you've watched the previous videos in this series, you know that I got as far as resolving an issue with the power supply in the main chassis, and then I started looking at the main PCB. So I've made up a jumper connector so I can run the board out on the bench, otherwise it has to be attached to the main chassis, and it's very difficult to work on because this is then the inside of the board. So I've made it possible to work on the bench like this. It makes it much more convenient, and of course it makes it easier to shoot these videos as well. Now, I don't have any technical documentation for this machine. I don't have a schematic, and what is typical of machines of this era is the excessive amount of glue logic that was used. They seem to throw extra chips at problems rather than possibly simplifying the arrangement, and it does make it extremely difficult to work on machines like this when you don't have a schematic. So what I've been doing since the last video is having a quick probe around. I found that 6 out of the 8 main DRAMs were faulty, so I've replaced them as a set of 8. 3 of the video RAMs were also faulty, so I put a new set of 4 in. I popped out the SRAMs and tested those, but they tested fine, so I've socketed those. They were soldered in, but I've fitted sockets to make it easier should they ever need replacing in the future. And I've popped a few of the other ICs out simply because I don't think they're required for the machine to run, and it simplifies the overall fault finding task. I'm not sure what some of these actually do. There's an A to D chip here. I'm not sure what it's actually measuring, whether it's analog input or if it's part of the system. I have had the ROMs out and I've read the contents. They do seem to read okay, but of course I've got no way of knowing if the contents are actually correct or not. But what I get when I fire this up, I'll switch it on, CLT of course, so it takes a few seconds to warm up, is I get a blank screen. I got a completely dead screen before, but now it does light up, and I'm getting some patterning down the side of the screen. If I measure the output on the video controller chip, so this is the video controller chip, it's very similar. In fact, it's an equivalent type to the one you get in machines like the PET and whatever else. In fact, you can interchange the two types. But if I measure, I'm getting sync pulses, so I know that that chip is working to a certain extent. It would tend to indicate we're getting sync pulses because of the repetitive nature of the, if you look down the edge of the display. Also, if I hold the reset button in, it changes the nature of what I'm seeing on the display. You can see now it's stopped all activity. If I release the button, it comes back, and this is kind of indicative of this chip not being initialized. It's a very versatile chip, but it has to be programmed with the required parameters for the display that's being used, so refresh rate and the sync pulse rate, that sort of thing, and this tends to indicate that this is incorrect. So the first thing I want to do is have a look at the signals going to the video controller chip. Initially the machine wasn't running at all. There was no activity or no sensible activity on the Z80. I tried a new Z80, it made no difference. That came down to the DRAM, and now there does seem to be activity on the Z80. I don't know if it's correct. We'll look at that later if we need to. And the first thing, as I say, I want to do is look at the data going into this chip to see if it's actually being properly updated. So let's try rebooting with the SCURP attached. So the yellow channel, channel 1, is the one I'm using on this probe. So I'll reboot the Wren. Okay, it's clear that these lines are floating, so the system's not trying to write anything to the video control chip at all. That explains why it's not being properly initialized. This rubbish that we're seeing on the display is just because of whatever nonsense is in the video controller chip when it's powered up, and that most likely will change every time I power up the Wren. It's just random behaviour depending on, as I say, what is in the control registers of that chip when it boots up. So as you can see, this time we're getting nothing at all, and resetting does nothing, so it does tend to indicate there's nothing writing to it. It's just simply a case of whatever it boots up with, that's what we're seeing. Okay, but there's nothing on any of the data lines going into it, they're just floating. And because they're floating, it tends to lead me to suspect, or the first thing I would suspect is that the buffer that is feeding data to the data bus on this device is not working, or it's not being enabled. So I'll get a test meter and we'll try and find out where that device is. So it's most likely going to be one of these buffer chips. Okay, got lucky that time. So it's this one. So we'll check to make sure the signals we're getting there are the same as the signals on the video controller chip. So it was this pin, and as we can see they are indeed floating as well. So if we look at the chip enable pin, which I believe is that one, okay, it's permanently high. I'll try rebooting the Wren, see if it ever actually changes, and it doesn't. So that's staying high all the time, which means that the data being fed to its inputs, which should be on the data bus, okay, so as we can see, the output of this buffer chip is floating, so this is what's feeding data to this. This effectively connects the data bus on the video controller chip to the CPU data bus, and the outputs are floating. This is the enable pin, and as you can see it's never changing, so this is not being addressed. So I'll just check the input and see if there's any activity. So this is the data bus from the CPU. Okay, now of course there's any number of reasons this may not be being addressed. It could be that the logic that's feeding it is faulty, or it could be that the boot up sequence isn't getting as far as trying to initialize the video controller chip. As I say, I've got no technical information on this machine at all, so I don't know what the boot up sequence is. I don't know if it will boot up without the floppy drive connected. I don't know what the boot up sequence is in terms of if something fails before it gets this far, what will happen. I don't know the order of the boot up. So what I'll do is I'll just start off with the simple things. I know the CPU is running. We can see the activity on the data bus. So as a first step, I'll check the activity on the DRAM to make sure that we're getting data going into and out of those. Same with the SRAM. There's not much point checking the video memory at this point because this chip isn't running, so whatever's in the video RAM isn't going to make any difference. But the first thing I'll do is see what's feeding this control pin and just check that device to make sure it's not just a simple failure. These are normally fed through some sort of simple glue logic that gives a logical control of this chip based on a memory address or in-out address, or however the system's controlling access to the video controller chip. So I'll turn the Wren off. We use the same method for finding the device that's trying to control this. So you can hear it. I haven't got it on camera, but I've got the test meter set to beep when I get continuity. So it's this pin we're interested in. I want to know what's controlling this, and it's most likely one of the devices round here. So rather than trying to figure out which are inputs and which are outputs, the quickest way is just to run a test lead down all the pins on the device. So you don't push too hard, because you can damage tracks if you push down too hard. Okay, so what we need to do is make sure that's an output. If it's another input, then it's not controlling it, it's just being controlled by the same line. So that's a 7402. So yeah, that is in fact an output. So what I'll do is I'll test this device and make sure it's working before we go any further. I could hook a scope up, I may do that in a minute, but the first thing I'll try is using the logic comparator. So this is the device type 7402, and as we can see, this pin, this is the one we're looking at, is in fact an output. So the Wren's turned off. I'll hook up the logic comparator, and I believe it was that device. Okay, and then we'll turn the Wren back on. As we can see, we're not getting any errors, so that device is working fine, unfortunately. So I'll turn the Wren back off. And just to confirm that the logic comparator is doing what it's supposed to, we'll look at that device with a scope. So the output, as you can see, is permanently high, and both inputs are permanently low, which is why the output's never changing. So again, this kind of leads back to the point I just made, that this could be anything on the system that's stopping us getting that far. I may need to start looking at hooking up the logic analyzer and tracing the code through. But before I do that, we'll do some other simple checks. We'll test the data lines on the Z80 to make sure that they look fairly normal. That looks fine. That looks fine. That one doesn't look very healthy. Okay, so we may have something loading up that line. That one looks fine. Okay, so we have at least one data line, two data lines on the Z80 that look very poor. Normally they feed directly into buffers like this one, and I see there are a number dotted around. So what I'll do next is I'll probably pop these devices out and see if the data outputs on the Z80 look any better. It could be one of these buffers is failing and it's putting too much load on the Z80, and if it's doing that, it's going to prevent data from properly propagating through the machine, and of course that's going to stop it running the way it should do, and that in turn will prevent proper operation, including accessing the CRT controller chip. So I'll do that next. I'll do it off camera, and as I say, I'll find all the devices that are hooked onto the data bus. I'll pop them out one by one. It's generally the easiest and quickest way to do that. This board is quite nice to work on in terms of getting the ICs out. When I popped out the SRAMs, they came out quite nicely without damaging the board, and that was quite easy. So I'll do that. If I can find out what's causing the problem with the data output on the Z80, then obviously I'll replace the devices, and then in the next video I'll get back onto that and see if that resolves the issue. What I'll probably also do, I was asked the question in a recent video as to do I ever use something like a Fluke 9010 to do fault finding. And if you watch my videos, then you'll know that one of the things I do is produce vintage test equipment, and that includes pods for the Fluke. And one I happen to have done is for the Z80. So what I will most likely do is hook the Fluke 9010A up to the board. One of the things that it can do is learn and analyse the board to see where the ROM addresses are, where the RAM addresses are, what's input, what's output. Doesn't always work reliably, especially on a board that has faults, but it should give me a good starting point and allow me to do some testing, some specific testing on the RAM to see if the RAM's working, to see if the SRAM's working, and to see if the ROM can be accessed. Also, if I can find a checksum for the ROM, I can do an onboard checksum to see if these are being reliably addressed. I could put them in a programmer and read them, in fact I have, and they seem to read fine, but if there's an addressing issue on the board, then that could cause them to not be read reliably by the Z80. So before I move on to attaching the Fluke, it's always worth doing a quick check on the control lines on the Z80. As we've seen, the system's not running to the extent where it is trying to address the CRT controller chip. That could be anything, and one thing that's worth checking are, as I say, the control lines. So if we look at the IRQ, we are getting activity there. Request, obviously it is writing or addressing memory. That's the halt line. Non-maskable interrupts, so we're getting no interrupts on the non-maskable input. And on, okay, that's the software maskable interrupt input to the Z80. It should strobe low whenever there is an external interrupt being generated, and normally it's kind of a free-for-all interrupt input. It's any device on the system that wants to be able to create an interrupt is normally ORed with this input, but it should only strobe low, it should go high again. So what I'll do, I'll check to see if this is being controlled through any of the glue logic, try and find out what's driving that. The Z80 will only respond to that input if the internal interrupt flip-flop is set, and then it won't respond to it again until software comes back and resets that flip-flop. So it might be that it's already dealt with the interrupt and it just hasn't got as far as resetting it. Depending on the mode that the Z80 is running in, it will run in different interrupt modes, but depending on the mode that it's set to, it might jump to a specific address, so it's quite possible that the Z80 is simply cycling round a tight loop trying to service whatever's causing this interrupt line to be low. And I think the easiest way for me to do that is indeed to attach the Fluke and see what's actually going on, and the Fluke will let me examine that line and see exactly what the status is for the entire set of control lines. It will also let me examine the data lines to see if they are actually controllable. So I think I'll do that next, and that should give me an idea as to what the Z80 is seeing from the system perspective. It could just simply be that there's some glue logic device that's failed and it's just holding the interrupt line low, and the software is not smart enough to be able to progress beyond that. So that's what I'll do next. I'll attach the Fluke and see if we can make any progress that way. Anyone that has any technical information on this, schematics, etc., or any experience fixing these, then any advice or information would be most appreciated. Otherwise, what I'll have to do is just go through this slowly, trying to figure out exactly how it works. But if you've watched my videos on the ZIP30 teleprinter, you'll know that can be a very exhaustive and time-consuming task.